Hi, this is Sumin Choi, and this is my presentation. So first, I would like to go over roles of T and B cells in our body and their characteristics. And then I would like to explain why B cell deficiencies are more susceptible for bacterial infections and why people with T cell deficiencies are more prone to viral infections. Okay, so the role of T cells. The role of T cell is to circulate in the lymph and blood system to kill pathogens, just like B cells. And T cells create different T cell receptors by combining different parts of DNA. So in chromosome 6, they combine different parts of the genes to make different combinations. And for T cells differentiate into three different types: cytotoxic T cells and helper T cells and regular T lymphocytes. And the major role for cytotoxic T lymphocytes is to kill other cells. It can be within our own body cells, or it can also be our body cells that's infected with virus. And helper T cell lymphocytes, they regulate the activity of B and T cells of cytotoxic T cells by providing signals, and regulatory T lymphocyte, they regulate T cells and suppress immune responses, and they promote tolerance. Okay, so the characteristics include they come from the bone marrow, and from the bone marrow they roam around the blood, and after they roam around the blood, they go to thymus, and those chemiotic molecules are the ones that attract T cell molecules, and thymus. In the thymus, after T cells mature, they go to the lymph node, blood, spleen, and Peyer's uh, patches. So here's what I mean. So if you guys see on the rectangle thymus, that's where they actually uh, that's that's where they actually mature, and after they mature, they go to different parts of like cervical lymph nodes and abdominal lymph node, different parts of lymph nodes, and Peyer's patches, well, appendix. Okay, so these as you can see, stem cell from bone marrow, they get actually created, and they make T cells from there, and this is the T cell receptors that is on the T cell. Okay, so what's the primary defects of T cells? Is of course Dye-George syndrome, and so they are unable to make T cells, and those that's the primary immune deficiency disease, and um, there is um, there is no cell mediated immunity. So it's due to the fact that thymus fails to function, and they're particularly vulnerable to virus. So if you actually look at thymus, because their function is gone, they cannot actually create T cells. Okay, so why is that? We want to talk about why is so actually, what I found out was Immune Deficiency Foundation. That's the website from primaryimmune.org, and they actually mentioned that T lymphocytes they directly kill virus, and T lymphocytes also help B lymphocytes to develop into antibody by producing plasma cells. But here's the thing. So as we know, when virus affects our body, invades our body, they hijack our DNA, and those DNAs are going to be replicated, and later on they replicate using our enzyme systems and other uh, other materials to replicate. So the bacterially infected cells. So what um, T cells for cytotoxic T cell do is they when they attach to the infected ones, they release all those active enzyme to induce apoptosis. That means killing of our cells. And when those kills, when we are affected with virus, especially cold or COVID or whatever, they what they do, they kill our own cells that are infected with virus to stop the viral spread. So we can easily guess that if we don't have T cells that can protect our body, then we'll be more vulnerable. Okay, so I would like to go over the role of B cells. And with the random combination of gene materials, they make antibodies. So the primary goal is to make antibodies, and their defense mechanism of antibodies include activation of complement, inflammation, neutralization, optimization, agglutination, and ADCC. Those are the 5 ways in which they do the defense mechanism in our body. Okay, so just like T cells, they use different kinds of gene combination to formulate different types of antibodies. And from the red bone marrow, B lymphocytes are created, and they roam around spleen, mouth, and primarily follicles of lymph nodes. Okay, so these marks, they roam around those places. And I forgot to mention that here T cells meet anti-loaded dendritic cells. That's from those sites where like lymph nodes and Peyer's patches, they meet dendritic cells to gain more information. And same goes here. And here's an example. So dendritic cells contact with TH cells, and TH cells contact with B cells. But I guess I digress a little, but that's how it works. But I would like to go over primary defects of B cells. So patients with boron type immunoglobulin are unable to make immunoglobulin, and those immunoglobulin is going to people are going to be more vulnerable bacterial infection. And as you can see, this is one of the articles I found, that Bruno Gramolia and Burton Gramolia, and he says that primary reason that they are susceptible to bacteria, certain kind of bacteria, the reason that, like, these are the 3 types of bacteria that are particularly susceptible, and it's because the culprit is because they lose the optimized antibodies. So they lose this function. Optimization, as we know, help phagocytes to eat bacteria in our body, and primary defects in B cells is going to make our body more vulnerable to bacteria. So when you lose these kinds of antibodies to recognize the virus of the bacteria at the first place, then the phagocytes won't be able to engulf them. Okay, so one other primary defects of example that I found was Omenn syndrome. It was it's a syndrome that loses both B and T cells. But it was interesting because it's one of the symptoms was rhinitis rash, and it goes directly in line with delayed cell hypersensitivity, and where T cells attacks the body cells. And those allergic reaction from defective T cells are actually going to lead to allergic on our skin. So this is the type 4, and as we can see, I guess there can be both defect B and T cells, which can give us all different kinds of complications. And these are the uh, these are the external sources that I found. Also, and thank you very much for listening. Have a wonderful day. Bye.